Alrighty, in this video we are going to be talking about derivative rules. For now we're just going to talk about the power rule, which is going to be a lot of fun. But for number 3 and number 4, pause the video, use Wolfram Alpha to find the derivative of these, and then play the video once you are done. Hopefully you would realize that all the derivatives for number 3 are zeros. And the reason why is because all of these functions are constant functions. And if they're constant functions, you'll notice that our slope, because remember, derivative means slope, is 0. So a constant line has 0 slope. Number 4, you'll probably notice that these derivatives here are just going to be the slopes of your linear functions. So all of these are linear functions. And this kind of makes sense because if it's a linear function and we're finding slope, aka derivative, then the derivative is just the slope of the line. Likewise, for number 5, I want you guys to go ahead and pause the video, go to Wolfram Alpha, take the derivative of these, and then figure out the general power rule. You'll probably notice something very interesting going on here with these derivatives. If you notice that, if I were to look at the exponent right here, notice how my exponent now becomes my coefficient, and my exponent is 1 less degree. So that represents the general power rule. So if I have x to the n, then my derivative is going to be n times x to the n minus 1, provided that n can't be 0. For the function. There are a couple more derivatives like you'll need to know. We've already discussed cosine and sine based off of our sketching lesson. So I know that the derivative of cosine is negative sine, and I know that the derivative of sine is cosine. The derivative of e to the x is just going to be e to the x. That one's special, so it just stays the same. And then the derivative of ln x is going to be 1 over x. All right, and these examples here, we can't really use the power rule yet because our function isn't really in polynomial standard form. So what we're going to do here is put this in standard form and then take the derivative using our general power rule. So for this one right here, I'm going to go ahead and rewrite this to be 9x squared plus 24x plus 16. And then using my general power rule, I'm going to take my exponent, put it down as a coefficient, so that becomes 18, and then subtract my exponent by 1. So 9x squared gives me 18x. 24x is going to give me 24. And then the derivative of a constant we saw is just going to be 0. So my derivative of 3x plus 4 squared is going to give me 18x plus 24. Likewise, for this one right here, I am going to divide everything by x squared. Then I am going to take the derivative of each. So the derivative of a linear function, remember, it's just the slope, so that's going to be 5. The derivative of a constant, 3, is just going to be 0. Here I'm going to multiply my exponent with the negative 7, so that becomes a positive 7. And then I'm going to subtract my exponent. If I subtract my exponent, I'm going to get negative 2. Likewise here, I'm going to multiply negative 2 with my coefficient. That's going to be negative 2, and then I'm going to subtract 1. That gives me negative 3. Now, the good thing about the AP exam is that you could leave it like this, unsimplified. and, you'll be good. Now, on the MCQ, of course, if you see maybe the simplified version, aka the clean version, you'll probably get something like that. All right, let's do the third one. Same thing here, but we're going to have to do two things. We are going to have to expand the numerator. And then after expanding, I am going to divide by x. Nine over x, which is the same thing as 9x to the negative 1. I'm going to take the derivative. So the derivative of x is just 1. The derivative of 6 is going to be 0. And then if I take this derivative of 9x to the negative 1, I'm going to get 9 times negative 1. And then subtract my exponent to be negative 2. So I have 1 minus 9x to the negative 2. Now, you'll notice that I did label what my f of x is and what my derivative was. So whenever you are working out your problems, please make sure that you label what f of x is and what your derivative is so that you're not getting confused and I won't be confused whenever I grade your quizzes and whatnot. All right. Number 8. I have this function right here, and I want to answer the following. 8 says, find the average rate of change from 1 to 4, and average rate of change is just regular schmegler slope. So here, I'm just trying to find the slope between x is equal to 1 and x is equal to 4. So I have f of 4 minus f of 1 over 4 minus 1, and I'm just going to plug in 4 and 1. So f of 1 is just 1 plus 1. Or 2. And then f of 4, if I plug that in, I get this mess right here. Now remember, on the AP exam, I don't need to simplify anything. So here, if I wanted to put this in the unsimplified version, I can do that. I am going to simplify the 4 squared and the 4 to the negative 2, though. So that's f of 4 minus f of 1 all over 4 minus 1. And that right there is your average rate of change from 1 to 4. Keep it like that. Even though it's nasty, just keep it like that. You'll be okay. And the graders will be okay. Instantaneous rate of change at x is equal to 4. So here, whenever we're talking about instantaneous rate of change, remember that we're talking about the derivative at x is equal to 4. So I'm going to take the derivative of this. So I have f of x. Let me simplify this first. So I have x to the 2/3 plus x to the negative 2. If I take the derivative of that, I'm going to get 2/3 x to the negative 1/3 minus 2x to the negative 3. All right, so that's my derivative. And then if I want the instantaneous rate of change, I'm just going to plug in 4. So f prime of 4 is going to give me 2/3, 4 to the negative 1/3, minus 2, 4 to the negative 3. And once again, just leave it like that, even though it looks nasty. The graders will be okay, and I will be okay. Part C, find the equation of the tangent line at the point when x is equal to 1. Well, we already saw from part A that the y value for 1 was 2. So I have a point already. Great. Now to find the tangent line, remember I need slope. So how do I find slope? Well, I got to find the derivative. We already found the derivative here in part B, but now I just got to find the derivative at 1. That's 2/3, 1 to the negative 1/3 minus 2, 1 to the negative 1/3. Obviously, that's just going to be 2/3 minus 2, which is the same thing as negative 4/3. So you have your slope of negative 4/3, and then you have your point of 1, 2. So to find your equation, you're just going to have y minus 2 is equal to negative 4/3, x minus 1, and call it a day. All right. So that is the power rule. In the next video, we'll talk about more on applications on rates of change and all of the other good stuff.